from LJ Institutes of Engineering and Technology. In this current video lecture series, we are studying the subject of Physics Group 1. Till now, we have learned what is elasticity, concepts of load, concepts of stress and strain along with the Hooke's law, and also we have discussed working stress and factor of safety. Now in this video, we will learn the topics such as elastic behavior of solids, factors affecting the elasticity, types of elasticity and types of elastic moduli. So let us start with the first topic of today's session, that is elastic behavior of solid. But before that, let us recall the definition of elasticity. The property of a material to regain its original condition on removal of deforming forces is known as elasticity. Solid exhibits three types of behavior when subjected to an elastic loading, as discussed below. The first one is elastic after effect. When a body is subjected to the tensile load, then it is expected that the body will gain its original position after unloading. This is the ideal condition. In actual condition, this process of regaining original position is not instantaneous. Few materials take time to regain its original position. The delay in coming back to the original position is termed as an elastic after effect. This elastic after effect is very short for quartz and phosphorus bronze fiber. So quartz fiber is used in galvanometer coil and electrometers. Next is elastic fatigue. As we know that when an elastic body is loaded within the elastic limit and kept strained for a short time, extension is produced in it, and on removal of load, it is expected to regain its size. If such elastic body is subjected to this type of loading and unloading conditions, then it becomes less elastic. Due to the continuous alternate strain, the elastic body becomes fatigued. This phenomena is known as an elastic fatigue. So, a body under this kind of repetitive alternate loading will break under a stress less than its normal breaking stress, even within the elastic limit. Elastic hysteresis. When an elastic material is subjected to a stress, it will develop strain. On plotting the stress strain diagram during the loading path as shown in figure. Now, when unloading is carried out, it is expected that the strain will follow the reverse path to reach original zero strain position, which is followed during the loading condition. But the material follows entirely different path to reach zero strain position while unloading. So there will be two different curves on stress strain diagram, as you can see in the figure. This phenomena in which the material observes two different stress strain diagram is termed as an elastic hysteresis. This is the reason why the value of a strain for some stress are different while increasing the load and decreasing the load. The area under the curve of stress strain diagram is known as an elastic hysteresis load, and it is numerically equal to the work done in loading of the material and unloading it. Now, next topic is the factors affecting elasticity. So, first factor that affects the elasticity is the effects of stress. A material loses its elastic property even within its elastic limit if it is subjected to a large number of cycles of stress. Another factor is the effects of annealing. Annealing is a heat treatment process. The process of annealing decreases the elastic property of the material due to the formation of large crystal grains. Another factor is effect of hammering and rolling. Hammering and rolling breaks up the crystals into a small unit, and hence the process increases the elasticity of the material. One more important factor is the effect of temperature. The elastic property of a material decreases with the increase in the temperature. For some materials, let us take the example of carbon. Carbon is elastic in nature at the room temperature, but if we increase the temperature, it will become plastic. It is formed as a plastic at an elevated temperatures. Let us take the example of lead. Lead is in plastic nature at the room temperature, but if we decrease the temperature, it will become elastic. There is some material known as an invar. Invar is a material which is having an exception of the effects of temperature. With the change in temperature, there is no effect of elasticity is seen in the material of invar. Now next factor is effect of impurities. The elastic property of the material depends on the percentage of impurities added in the material. The increase or decrease in the elastic property is dependent on the type of impurities added to it. For example, when potassium is added to the gold, elastic property of the gold increases. When carbon content is added to the molten iron more than 1%, then elastic property of carbon decreases. So that was all about the factors affecting the elasticity. Now let us discuss the types of elasticity. Now the first type of elasticity, as you can see in the figure, is the elasticity of extension. The forces which produce the change in length of a member and member regain its original shape after the removal of the forces is known as an elasticity of extension. You can see in the figure, the length is increased after the removal of the forces. Again, it will take its original shape. The vice versa is also possible. If compressive force is applied, the length of the material will decrease, and on the removal of a force, it will regain its original shape. So that also comes under the elasticity of extension. Now next is the volume elasticity or the bulk elasticity. When a body is subjected to a forces produces change in volume, body regain to the original shape after the removal of the forces. Such elasticity is known as a volume or bulk elasticity. Now the last one is the elasticity of rigidity. The force which causes the deformation in the consecutive horizontal layers of an object relative to one another. When the deforming forces is removed, the body regains to its original shape is called as the elasticity of rigidity. As you can see in the figure, right now the shape is changed, but on removal of forces, the body will regain its original shape. So such a kind of elasticity is known as a elasticity of rigidity. Now next is types of elastic moduli. So the first one is the Young's modulus, another is bulk modulus, and third one is the modulus of rigidity. So let us discuss the first one, that is the Young's modulus. It is defined as the ratio of longitudinal stress to the longitudinal strain. If the load is applied to a wire of length L and cross-sectional area A is equals to pi r square is mg, and the extension in the wire due to this is delta L, then Young's modulus Y is given as longitudinal stress as force upon area, and longitudinal strain as delta L by L. So the equation becomes Y is equals to mgl by A delta L. Here it is important to note that the unit of Young's modulus is Newton upon meter square or the Pascal. Now next is the bulk modulus, or it is also known as the volume modulus. Now it is defined as the ratio of volumetric stress to the volumetric strain. If the load is applied to a substance, then only change in volume will be there. Thus, the volumetric stress is nothing but the pressure. Due to the normal force, the change in volume is delta V. Then B is nothing but the bulk modulus is equals to P by delta V by V. So on rearranging, we get the equation bulk modulus is equals to P into V by delta V. Here again the unit is Newton upon meter square or the Pascal. Now the third and the last one is modulus of rigidity. It is defined as the ratio of shearing stress upon shearing strain. In some books, the notation eta is replaced with G. If capital G is given there, then consider it to be a modulus of rigidity itself. Okay. If tangential load is applied to the surface of the substance, then the shape of the substance will change. So modulus of rigidity is given as force upon area, that is shearing stress to the shearing strain, that is theta. So modulus of rigidity is given as F upon A theta. Also the unit is Newton upon meter square. Now in the next video we will learn how to calculate the time period of a torsional pendulum and work done in stretching the wire. That's it for today guys. Thanks for watching.